Thanks. I don't know whether you can see it, but I love this, my newest wallpaper. It's a cookie summoning a cookie monster. Anyways, the thing that I really enjoy about the English language is that you can take nouns and put them next to each other, and people don't know which one is actually a noun and which one is adjective and which one it might be is, verb. So what do I mean by Ruby smells? I realized just actually yesterday that might not be, that this might not be the nicest thing to say at the Ruby conference, that Ruby smells, so please let me first explain what I mean by it. Do I mean that Ruby the language smells? Well, no. I really like Ruby. I've been programming Ruby for many times. I dabbled with some other languages, most recently Rust, which is awesome, and Crystal, which is also super nice. So I don't mean that Ruby the language smells. There are some parts that might not be ideal, like the fact that everything is public by default. In Rust, everything is private by default, and it turns to be actually quite useful. And in Ruby, everything is mutable by default, which is convenient, but again, in Rust, everything is immutable by default, and you have to say that things are mutable, and it has actually very, very large consequences. So there are some things that are not ideal. My biggest pet peeve is that enumerable, which is a wonderful thing in the Ruby language. It's my favorite module. It really shows what's so wonderful about Ruby, but at the same time, when you mix in enumerable into your collection class, all of the methods return arrays, not your collection class, so you have to redefine those methods anyway if you want to, for example, get a sorted collection, but wrapped in your collection class. So there are some minor words to the Ruby language. Everybody has their own. These are probably mine, but I don't mean that Ruby the language smells. I also don't mean that the implementations smell. We had a Cambrian explosion of Ruby implementations in the past. Some of them are long gone, like Iron Ruby, which was Ruby for .NET. Some new ones show up. Opal is Ruby for JavaScript. To some extent, you can write JavaScript in your Ruby. And some of them are really, really nice. For example, JRuby is one of the, I think, most impressive alternative Ruby implementations. And there are actually things where JRuby is the best Ruby implementation. Sorry, Koichi. But also, I personally still use CRuby most of the time. So there are some minor things about Ruby implementations, like there's this method in matrix that has 433 lines. There's also this method that has 759 lines. And these are all in style libraries, so it means all of the Ruby implementations actually use them. And there's also this wonderful method that has almost 1,600 lines. And, but still, this does not mean that the methods are wrong. It's just maybe they should be refactored. Because when you start a new programming job, you have to walk right up to the biggest function in the yard and refactor it in front of everyone. So anyone that tells you that those methods are wrong, just ask them to refactor them. Because if you looked at them, you would actually be super impressive by the people who wrote them. Impressed. So am I saying that your Ruby smells, the code that you write? Well, actually. But also, the Ruby I write also smells a lot. And this does not necessarily mean that this is a bad thing. It's just something that we should probably pay a little attention to and try to investigate why the code smells are there. So let's see what a code smell is. This is the article by Martin Fowler, which basically says that a code smell is a surface indication that usually corresponds to a deeper problem in the system. The quick definition above contains a couple of subtle points. Firstly, a smell is by definition something that's quick to spot or sniffable. A long method is a good example of this. Just looking at the code and my nose twitches if I see more than a dozen lines of Java. This article is from 9 years ago, which explains the strange language choice. The second is that smells, and this is super important, the second is that smells don't always indicate a problem. Some long methods are just fine. You have to look deeper to see if there is an underlying problem there. Smells aren't inherently bad on their own. They are often an indicator of a problem rather than the problem themselves. And there's a WikiWiki web entry that I won't go over very much, just quote some minor things. Here at the bottom, note that a code smell is a hint that something might be wrong, not a certainty. A perfectly good idiom might be considered a code smell because it's often misused, or because there's a simpler alternative that works in most cases. Calling something a code smell is not an attack. It's simply a sign that a closer look is warranted. And this is also very important. Rules are for the guidance of the wise and for the obedience of fools. There are two major approaches to programming. Pragmatic code smells should be considered on a case-by-case basis, and purist, all code smells should be avoided, no exceptions. And this is a part of the reason why Kent Beck and Martin Fowler chose this name for the term. They wanted to emphasize the pragmatic view of code smells by the connotation of the word smell. If something smells, it definitely needs to be checked out, but it might not actually need fixing or might have to just be tolerated. This is super important. It doesn't mean you have to fix them unless you're a purist. It might be useful in your research or getting better as a Rubyist to try to fix all of your code smells and learn the hard way. Guess how I learned the hard way? Because I have this purist leaning now and then, but only in my own personal projects. But it's super, super useful to learn when a code smell is problematic and when it should be accepted or actually is the right choice. So there will be a lot of code examples in this talk, so a few caveats. The instance state is denoted by via instance variables. Just assume that those instance variables are set in constructors or dependency injected. I won't have constructors for simplicity, but just assume when you see an instance variable, it somehow got there and is set in that class. And I actually don't use instance variables in my personal code. I use getters because I just prefer it. It's a personal preference. I wouldn't write this code like that in my production code or in my personal code, but for the sake of this talk, I kept them as instance variables because it's very easy to recognize which is the state of which parts come from the state of the class. And some of the examples are very badly refactored just for the sake of showing example refactorings. One of your homeworks is to decide whether the refactorings are any good. So let's start with the first example. Let's say there's a conference class, and as I'm from a very northern country, if the skies are clear, I consider it a bit too distracting. And if the temperature is too high, which is 20 plus, I consider it too hot, but otherwise the weather is perfect for coding. So we have our Confluence class, we have our weather assessment method, and it consults some weather source, which is a dependency of this class, and we check the weather at the city of the conference. So weather source and city are the instance variables of this class, and we ask it whether the skies are clear or whether the temperature is above 20 Celsius. So what's the problem with this implementation? In practice, in many cases, especially in the case of weather checking, those calls can be expensive, and they can go over a network, they might not be cached. So doing the multiple call here, like twice the same call, usually is a code smell, because it means that probably this should be refactored, and there is probably no reason to ask the weather source for the same weather twice in a row. Like, there's a very little change that the weather changed between the if and else lines, and if it did, it usually means that the questioning the weather service takes a very long time, so this method is very slow. So this is a prime example of duplicate method call, and it means that the same call is made more than once. The obvious refactoring is just to factor it to a single call. The caveat, and I will actually, so this is the simplest code smell. You could say like, okay, this is obviously wrong, like, and the refactoring is obvious, but I will show you two examples where I tolerate this in my code. So the obvious refactoring is just to factor out the call once and just put it in a weather variable and then question that weather variable, whether the skies are clear and whether the temperature is high enough. But, for example, here are two cases where I don't think this warrants a refactoring. This is an implementation of something that uses a bit matrix underneath, so a matrix where there are rows and columns, and the values are zeros or ones, and it checks whether this bit matrix separates a given row from the given column, and it checks whether the row actually exists, and then whether the column in that row is a non-zero value, which means 1. And this is actually a duplicate method call from the point of purist view, because this is a square brackets method call on the matrix object, and this is the exactly same square brackets method call on this matrix object. It could be refactored to have first like row equals matrix square brackets row, and it might be faster, but this is super readable. This, for me, I just look at it and I see, okay, we check whether the row exists, and then what's the value in the column, in the given column. Here is an example of a method that takes a binary function of given inputs and outputs and checks how many quarters of a digital circuit it will actually take to implement. And if there are 0 inputs, 0 outputs, then it will obviously take 0 logic. If there are fewer than 5 inputs or 5 inputs, so fewer than 6, then it will take half the number of outputs rounded up, and otherwise it will take either half the number of outputs or 1/5 of the number of inputs rounded up, depending which is higher. Again, this is a duplicate method call because we divide the number of outputs by 2 and round it up twice, but this is in general A, more readable, and B, those two branches will never be executed at the same time because either the number of inputs is fewer than 6, which means this will be executed, or not, which means this will be executed. So again, technically this is a duplicate method called code smell. In practice, I think this is more readable. So always, always question your code smells. Okay, let's go further. Let's say our conference class has directions method that shows you directions to the conference, distance method that shows you a distance to the conference, and a needs passports predicate that tells you whether you are crossing any borders that actually have passport control on them. So you pass your latitude and longitude to those methods, and then these methods query some kind of navigation source and ask them for the directions or distance or borders checked between this latitude and longitude and the conference's latitude and longitude. So these are instance variables, so this is something that belongs to the class. It might not be obvious for you. Eventually, it probably will get obvious to you, but all of those methods take 2 parameters. They're exactly the same 2 parameters. And this smell is called data clamp. So every single of those methods takes exactly the same parameters, exactly in the same order, and also exactly the same named. So a data clamp code smell is when the same set of variables is passed in many contexts. Refactoring is to create a composite object. Usually it's a value object because usually these are value objects themselves. And caveat, make sure the clamped variables are actually related. If you ever worked with a code base where everywhere there are some contexts to be passed, and those contexts are those magical objects that has 20 methods that return unrelated things, this is an example where somebody really turned data clamp fixing to 11, and I'm always scary when I see a code base where there's a context object, because it usually means I will have to think very hard about what the context actually is. But in general, in this obvious example, the best refactoring is just to create a location struct that has latitude and longitude, and then pass this location to all of the methods, your location as this structure, and the conference's location as this structure. So next, let's look at the case where we got the conference location, for example, from the name of the city, and we used some geolocation service, but the geolocation service was down, or for some reason, it doesn't work for the given name of the city. So just to be safe, we guard all of those methods in the if location check. If location we were able to determine location, we can return the directions, distance, and borders, but if not, then it just returns nil. When you have this many if checks on exactly the same condition, is called repeated conditional, and it basically means that the same condition is checked in many, many places. The refactoring is a bit more complicated. There are a few ways to refactor this. One of them is to have a conference that doesn't have a location and a conference that has a location. This is super tempting, but you should always check whether it actually works for you, because if conferences have many variables that can be nil or not, then you suddenly have located conference that has a name, a located conference that doesn't have a name, a conference that has no location and no name, and so on and so forth. Another refactoring that I actually would probably try first is to have a null location. So a location that is a location that doesn't exist or couldn't be determined, but still works as a location object. This here is actually a bit tricky, because what does it mean that you have a null location? Like, where is it when it's a null location? So this is also not an obvious refactoring here. But if you could make your navigation source work with null location, then you could, again, rather than this code, have this code here, where you pass it whatever location you get. It might be null location, but the navigation source will deal with it and respond, for example, with null navigation object, rather than nil, which is one of the big smells in Ruby code bases, that everything can return something or nil, and you have to deal with it when you call the methods. Let's go further. This is probably the most questionable one in this talk. This is not because of the contents, but I'm sorry for that as well, but this is a method that takes an attendee parameter and then checks whether the attendee is Pythonista and then determines that the conference is interesting if it's about dynamic languages, whether there are Rubyists, and then it checks whether the conference is laid back enough, and then it checks whether it's Rustasian. There's a separate talk by Steve how to pronounce it tomorrow, so apologies for in advance, you'll know tomorrow, but it checks whether the conference is about system languages. So this means that the code that calls this method determines how this method will work. So it's a control parameter. The caller knows which path the code will take. The refactoring is to split this into dedicated methods because the caller knows exactly which one will be called, with the very large caveat that it might actually not be as usable as in theory it is, because maybe that the caller got this attendee object from somewhere else. And to know which method to call, it would actually have to analyze and have this logic in the caller. So the pure implementation, refactoring, is to have an interesting to Pythonistas query method that checks whether it's dynamic. So these are basically aliases. But also, again, this is an example where I think a code smell, a typical code smell refactoring, goes a bit too far, because I don't think that would be reusable, even if you actually accept this is a valid example of a code, which probably it isn't. But there is a special case of control parameters that I think usually warrants refactoring, and this is this case. Let's say that we say that the conference is about Ruby. It's probably strictly about Ruby if it has Ruby in the name, like RubyConf Portugal, or it might be about Ruby non-strictly if it has Ru in the name, like Baruco or Yuruco, for example. So we have a Ruby predicate. We pass whether we want a strict check or non-strict check, and then we know whether the conference is about Ruby. So this is a Boolean parameter. The caller directly controls callee's code execution. So the caller exactly knows whether this code path will be taken or this code path will be taken. The caller basically tells the other object which code path it should execute. And the obvious refactoring is to split this into dedicated methods. In certain contexts, it means split out a separate class. And again, consider caller usability. But in this case, usually this code smell warrants refactoring. So a typical refactoring would be to have a surely Ruby predicate method and possibly Ruby predicate method, because the caller exactly knows which of those, if they are still put in one method, which of those will be called. Okay, so let's go a bit further. Think about what's interesting about this method. So you probably thought that interesting thing about this method is that it only calls methods on its parameters. You could take those 4 lines from dev to end, put them anywhere in your code base, and it would work. You could put it on any object. You could put it on kernel. You could put it on, whatever fancy class you have, and it would work just as well. You take a collection of attendees, you pass it to this method, you know whether a conference is successful, which means whether there are more excited than indifferent attendees at the conference. This is called utility function. This means that a method that does not depend on instance state. There is no instance state on this method, so you could take this method, put it anywhere. You could make it a class method, you could make it a method, you could make it top-level method on the main object. It will work just as fine. So it can be moved anywhere in the system, and the refactoring is to probably figure out where it should be moved. Or maybe it actually depends on instance state. And sometimes it's just a private helper. And I will get back to this later in the talk, but sometimes it actually warrants to have this kind of methods because, for example, you're formatting output of your object, and it's simpler to move it to a private method and to pass the thing that you want to format as a parameter rather than force the thing you want to pass into an instance variable and pass it implicitly as object state. Sometimes utility functions as private methods work actually better than trying to move them somewhere else. One of the refactorings is to just accept that attendees are a crucial part of a conference and just make them an instance variable and do like this. But still, this works more on, it seems it tries to add logic to the attendees collection that the attendees collection doesn't have. So maybe the right thing would be just to say that the conference is successful when the attendees are excited, and the attendees are excited when the collection that represents attendees actually has this logic. You can inherit from array, but inheriting from array is not usually a very good thing for many reasons. One of the reasons is also that suddenly the attendees class has all of the methods that the array has, which might not be what you want. So you can do something like this. You have a collection class attendees that takes an array of attendees and stores them somewhere inside. It delegates the partition method to the attendees, and then the only public method it has, other than the partition, but it could be actually made private, is the excited predicate. And if you don't know how partition works, it's basically a method on enumerable that splits the enumerable collection into two collections that pass this block. So this splits them into excited and indifferent. So this is one of the examples of refactoring. Let's go a bit further. Let's go to a case where it's not so obvious. Let's consider a conference successful when the attendees are excited, but let's consider attendees excited if they are inherently excited, or maybe the conference is about Ruby and the attendees are actually Rubyists. So they might be inherently excited, but they actually are excited because the conference is about Ruby. So this is a bit more tricky because this method suddenly depends on the instance state. Even though we pass the collection of attendees, it actually has to check whether the language of the conference is Ruby. So this is still this method. Other than this simple part of it, it's all about the attendees. So it's not a utility function. We couldn't move it to an object that doesn't have the language instance variable and expect it to work, but still it operates almost exclusively on the attendees collection. This is called a feature envy. This class is basically envious of what the attendees class knows. And it means that it partially refers to instance, but mostly to its arguments. Here we have one argument, but it could as well be a case where we have 3 arguments to a method, and the method operates mostly on those arguments and not on the instance state. The refactoring is to move the code to one of those arguments. Caveat, make sure the knowledge is local to the problem. So if you have a case when you have a huge object that does one thing in your system and it's the only object that does it, then suddenly if you move all of the little things that it needs to do to all of the objects it cooperates with, then suddenly you have many objects that have very small pieces of this knowledge, and this object doesn't have it. It usually means that the initial design was really bad, or this object has way too many collaborators, which is the reason behind the quote that the code smells sometimes indicate a problem with architecture, not necessarily with this piece of code, but sometimes just make sure that the knowledge is actually where it belongs. So for example, we could pass the language to the excited predicate, and then the attendees could check with every attendee whether they are excited given the language of the conference, and then the attendee could say that they're excited if they're inherently excited or they're a Rubyist and the language of the conference that got passed is Ruby. This is an example of not necessarily a very good refactoring, in case you were wondering. Just a simple thing that probably should be refactored further. Okay, let's go to the last example, last code smell example. This is a conference class that has a city and a name, and it has attribute accessors for both city and name, which means both the city and the name of this conference can be set from the outside, which means there is an object that every other object that collaborates with it can change its state. This is called the attribute smell, at least in the software that I will show you in a minute. And the basic premise is that setters in general are bad. There are some people who question this. There are cases where setters are warranted, and there is a way for your objects to control whether the setters are called. If you define a foo equals, or if you define city equals something method, then the conference class can control when somebody tries to set a city on it. But in general, they are at least something that should be visited and check whether they are actually needed. When it comes together, it really depends. There is the school of object-oriented programming that says objects should have state and behavior, and if your objects only have state, which means getters make a lot of sense, because if your objects have state and don't have behaviors and don't have getters, they are kind of hard to work with, probably. So if your objects have getters, it kind of depends. Value objects with getters, I'm perfectly fine with them. Other objects with getters usually mean that maybe you should try to use the tell, don't ask principle and try to tell them what to do rather than to ask them what their state is. And the other thing that I started doing in my code bases and I really enjoy is try to have immutable objects. So whenever I try to mutate a state of the object, I just return a new object that is almost the same as the old object, but with the one little thing changed. And the typical names for the method that returns the mutated or changed copy of the object is update or with. And the caveat here is getting rid of setters might be an overkill in simplest projects, but also the caveat to the caveat is that usually the projects that are considered to be simple and just one time turn out 5 years later to be much larger and still there. So in general, probably avoiding setters is a good thing. So for example, in this case, a refactoring could be to just have the getters and then have an update method that potentially takes a new city, potentially takes a new name. I don't know whether you knew this, but you can actually default your method parameters to the instance variables of the state. So if you don't pass a name, just change the city, then this variable, which is here, will default to the instance variable of this class. And we just return a new instance of the same class with the city and the name. If somebody passed both city and the name, we return a new instance of the class with new city and new name. But if somebody just passed a new name and the same city and didn't pass a city, then this class returns an instance with the old city and the new name, but it's a separate instance. This instance is never mutated. There isn't a very efficient way to make sure your Ruby objects are not mutated. There's an Adamantium gem that tries to ensure that the objects are not mutated, but it turns out it has very, very high performance cost. You basically try to freeze the objects and all the objects that are passed to the constructor, and it turns out in Ruby it's really expensive. But one of the good things you might want to try with your code base is try to make your objects immutable, and then try to fix your code base because it will start blowing up usually. So one of the good experiences is try to freeze your objects, make them immutable, see what breaks, make those code changes to not break your code base. Usually, or okay, that's probably too strong, but in many cases, it will yield a better code base. There is a person, that's the evil Tom Stewart, and he had a wonderful talk with James Coglan, I think 2 years ago at Eurocamp, called Burn Your Getters. You should watch the talk. The slides, my slides will be up later. They're actually up already, but if you click Tom Stewart, you will get to the presentation that they gave. Okay, so how can we find code smells in our Ruby app? So obviously, we can just look at them, and now we know what the smells, example smells are. But there's actually a tool that I help maintain that is called Reek, and Reek is a tool that goes through your code base and tries to find smells. So it's a very opinionated static code analyzer for finding smells, and if you know what RubyConf is, RubyConf is this obnoxious linter that basically says, this is badly indented, this string should be single quoted and not double quoted, which is a big issue in the Ruby community. This thing has too much, this method has too much white space around, this method is way too long. So Reek is like RubyConf, but for your architecture. It actually is very obnoxious, and it says, ha, that's a utility function, or oh, this is a feature envy. Come on, how could you write something like this? So if we try to use Reek, we just gem install Reek, and either we just run it and it just finds itself all of the Ruby files, or we can just run it on one file, and if we run it on our conference class without those refactorings, it will tell you there are 9 warnings, and again, these are warnings. These are just suggestions that you should take a look at the code, not necessarily this is totally wrong and you're a bad person. So conference weather assessment calls weather source weather at city 2 times. That's a duplicate method call. The conference takes parameters source latitude and source longitude to 3 methods. That's probably a data clamp. The conference tests latitude and longitude. So this is before the refactoring that introduced location. So initially, it has if latitude and longitude, if latitude and longitude. Reek checks, Reek finds repeated conditional even if the conditional itself is an expression. So Reek will tell you that this conference class tests latitude and longitude at least 3 times. The interesting predicate is controlled by its argument attendee. It's a control parameter. The Ruby predicate has Boolean parameter strict, and the implementation is controlled by this argument. So this is basically the same smell, but you can see that taking a Boolean parameter is considered even a bigger problem, potentially. So Reek shows you this as a separate smell. The conference successful predicate refers to attendee more than self, which is a feature envy. And the city is a readable attribute, so it's an attribute smell. And finally, the conference has no descriptive comment. It's an irresponsive module. I want to address this really quickly because there are 2 very strong sides to this discussion. One is that, well, code comments are a bit like this. And you shouldn't ever have code comments because it means your code is badly written and badly named. And then there's this side that basically says, trying to say that code comments are not necessary is a bit over the top. In my experience, I love to write very small, very idiomatic, wonderful code bases that don't need code comments, and I yet have to find production code that wouldn't benefit with a bit of code comments. And also, naming things properly is really hard. NP, as we know, stands for naming problem, and NP hard means a problem is as hard as naming things, which is the hardest problem we know of. If you think about it, you can infer what a CI problem is from that. So, how can we configure? We can configure rig. So we can create a .rig or config.rig or whatever file that ends with .rig, and we can say things that we are OK with in general as smells. And this will be the things that we ship by default. So we say that the data clamp is when there are 2 or more copies of 2 or more parameters. But you can say, like, OK, I don't really agree with that. I'm OK when there are 3. When there are 2 parameters, I don't consider it a clamp. When there are 3, probably I should factor out a common object. And you can configure that. We say that a method takes way too many parameters when it takes more than 3, except for constructors, which we say in general are a bit of a special case, so constructors can take 5. Again, you can change that. We say that a method takes too many instance variables when it has more than 4, and this is a recent change. It used to be 9. So we evolve the defaults. We are a bit more stricter, but again, you can say that's not right. My objects have many collaborators. I really like it that way. I won't have more instance variables in my code. And we say that a method has too many statements when it has more than 5, which is really restrictive in the case of production code, except for constructors, which usually tend to grow long. And factoring out stuff from constructors is doable and probably often warranted, but it's usually a bit harder and less readable than factoring stuff out of regular methods on your instance. So we say that we don't check constructors for the too many instance thing. And as you see, we can exclude things on a method-by-method basis, and we can say that we want to exclude a given class and its method, but we can also do all the way to defining this through regular expressions. So we can say, all of my methods that start with double underscores are actually helper functions, and I don't want ever rig to tell me that they smell of utility function. I know this, that's the point. So you can configure rig quite elastically, but also you might have this knee-jerk reaction. First, I can't have too many methods in a class, then I can't have too many code in a method. Something's got to give people pick one. Usually it means you probably need a bit more classes in your system that do a bit less stuff, each of them, but they are a bit better separated. But again, it depends. There are no golden rules. Code comments. This is actually my preferred way of configuring rig. You can do per method comments that say, for example, :rig, :utility function, and it means I'm aware that this one is a helper function. I know it smells of utility function. I'm OK with this. And also, you can locally configure stuff. So you can say, I know that there's a duplicate method call, and I'm OK with it as long as there's 2 of them. If I ever add a third call that is exactly the same, please make this smelly again. I will then refactor it. So this is my preferred way of configuring stuff. And finally, there's a certain popular Ruby project that has an app helpers directory, and those app helpers things are usually one big feast of utility functions. So you can say that, OK, app helpers directory, I don't ever want to hear that they smell of utility function. When we move from Ruby on Rails to software engineering, we will fix that on a case-by-case basis. Anyway, caveat emptor, making rig happy with my code taught me the most about OOP in the last year, but always be critical of such tools. In particular, feature envy was the one that opened my eyes the most. I was like, why are you so obnoxious? Why is it a feature envy? I would have to move it there to not, OK, it actually makes more sense there. So I highly recommend playing with rig on your code bases. There was a wonderful talk last year here by Piotr and his 2 premises that I found the most compelling were correctness verified by test comes before concerns about implementation details, and designing interfaces is more important than implementation details. The talk was Clean Code Cowboy. And I really, really want to stand behind those 2 statements. First, make your code testable and make sure that your tests cover all of the cases, or at least most of the important cases. Learn about mutability testing. And make sure that your interfaces between your classes are actually pretty well defined and work really nicely. And then you can actually refactor all of those smells away because you have full code coverage and the interfaces are stable. So don't get yourself into the position where I want to see a hacker movie where a protagonist just stares in confusion at a stack trace for a few minutes, no typing, no chatter. And remember that debugging is like being the detective in a crime movie where you are also the murderer. Like, don't refactor things so much that stuff breaks and you have no clue what's going on. So to wrap up, world domination plans, please try to rig. Please don't be overwhelmed by the potential smells. Please let us know what doesn't work. We usually have those conversations like, yeah, I played with Rig 2 years ago, and it just were too many smells in my code base. I got too frustrated, too sad, and I just deleted the gem and never used it again. Please don't do it. Please tell us what we should change in the default configuration to make your life easier. And have fun with refactoring and enlightened whitelisting. And this is my favorite quote. I have carefully trained myself out of who wrote this crap reflex. Now I cheer and say, yeah, sometimes in the past Yagni triumphed. Yagni, you ain't gonna need it. Don't make refactorings that don't seem to make a lot of sense. Finally, the code is more what you'd call guidelines than actual rules. And that's all I have. Thank you. The slides are up there if you want to see them.